Exercise 2, consider the function f of x in the domain -6 to 4. So let's have a look how this looks like. Let's zoom out a little bit so we can have a look where the maximum is of the function. We're going to go from, let's see, -1, 2, 3, 4, 5, 6. So from -6 to 2, 3, 4, x is equal to 4. Menu, zoom out. I'll click around here and then I can do again. Zoom box, I click somewhere here and then x is 4, so I include the minimum. Good, now I click on escape, go out to zoom mode, can move this out of the way, maybe here. First of all, determine if the function is odd, even, or neither. Okay, first we have to know the function of odd and even function. Sorry, the definition of an odd or even function. It's quite easy actually. If we just have a look at this, even functions. Let f of x be a real valued function of a real variable. This f is even if the following equation holds for all x and minus x in the domain of f. So basically f of x should be equal to f of minus x. What does this mean? The y value of any x, let's say 2, is going to be the same y value if we put -2. So let's have a look at this function, because this function is even. This is x squared. So let's take x is equal to 2, it's here, and then we go up here. What's the y value for this point? Well, y is equal to 4. So remember, we took x is equal to 2, and if we take -2, minus x, -2, we go up here. What is the y value? Well, it's 4 as well. So if we just pick any value, for example, x is equal to 1, we go up here, and then we look at the y value. Is it the same as if we go from -1 and go up and see the y value? Yes. So geometrically speaking, the graph face of an even function is symmetric with respect to the y-axis, meaning that its graph remains unchanged as a reflection about the y-axis. So this part will kind of create a mirror image on this side, reflecting about the y-axis. Okay, so you can kind of take this part and put the mirror image of that, and you will get this part. So if this is true, it means that the function is even. Well, is this function even? No, it's not even, because I can take, for example, this x value here, and I will get y around 2, and if I get 1, 2, 2.5, -2.5, the y value here is up here. So we can of course see that this is not a symmetric function in that sense. So it's not even. So what is the definition of odd? Here we see a picture of an odd function. This function is f of x is equal to x to the power of 3. So the definition of odd function, f is odd if the following equation holds for all x and minus x in the domain of x. So the y value and minus that y value should be the same as the y value for minus x. This might be a little bit more complicated to think what it actually means, but if we look at the graph, geometrically it's very easy to understand. Do you see the symmetry here? So basically, if we start from the origin, go up here, if you rotate this like 90 degrees, 180 degrees, you will get this part. Okay, so geometrically, the graph of an odd function has rotational symmetry with respect to the origin, meaning that his graph remains unchanged after rotation of 180 degrees about the origin. Example for odd functions are x, x3, sine x, etc. So if we just take the function and with respect to the origin, just rotate it 180 degrees, and you see the function is going to be down here, then it's symmetric in that sense. Then it's an odd function. And let's have a look at our function. If we take this function here and rotate it, only this part, it starts here and continues here. If we rotate it, it's going to be something like this, right? But if you look at this part, it's going to be a hill going up more like this, right? And then going down. So this is not an odd function, because then it would look, if we start here, something like this, then we are in the origin. Then it would be this part, but going up here, and then going down like this, and it doesn't. So it's neither. Okay. Find the coordinates of the point of inflection. We haven't spoken about this, but it's very easy to explain, so let's do that. Let's see if we can find a way to find the point of inflection. We're just going to analyze the graph inflection. And before we do this, you choose the lower bound, upper bound. We have to know what to look for. So basically, if we look at this function, how it changes, if you imagine a point here and the tangent to this curve, okay, you see the tangent to this curve, and it's changing and it's changing, and kind of here is a point where it's gonna change the slope of the tangent, okay. So basically, if I click a little bit left of this and then to the right, we have the inflection point here, and here's the coordinate. Here are the coordinates for that inflection point. So if you look at the derivative, the slope of the tangent will change and change and change, and then you have a breaking point, and then it will continue in the other direction. So let's say here it's negative, of course. It's gonna be let's say -3. The slope is -3, the slope is -5, -10, -11, -12, and then here is going to change and go back, -11, -8, -7, -4, -2, and here the slope is going to be 0. And then here it's going to start to increase the slope. It's going to be 2, maybe 4, 5, 10, 20, etc. So here's a point of inflection. And it's very easy to find that. Just go to menu, analyze graph, inflection. But you have to know what you're looking for. If you don't know, let's see if we can actually delete this point. Yes, and do it again. Let's say we don't know, we can't remember what an inflection point is. So we're just gonna inflection, we're gonna start to the very left. Remember, we're looking within we're analyzing the graph within the interval -6 to 4. So let's start around here, keep going, keep going, keep going. Here we see an inflection point, okay? And then we go to around 4. Okay, here's our inflection point. Number 3, find the equation of the tangent to f of x at the point where x is equal to 0. So let's plot one point where x is equal to 0. Just gonna go to menu, geometry, points and lines, points on the graph. So first I click on the graph, and then I click here. Now, since it's very common value, x is equal to 0, this is going to be in the origin. It will kind of snap into place. If we cannot get the exact value, let's say I click here, you see it says minus 0.166. I can actually click escape first, and then I'll move this up. I want to change the point to have the x value 0, so I'm just going to click. If it doesn't work, click escape, click once, click twice, and then I can start to delete this and say x value should be 0, and then press enter, and then it will move the point where x is equal to 0. Now I would like to draw a tangent to the curve that goes through this point. So I'm going to go again to geometry, points and lines, and I'm not going to draw a line, I'm going to draw a tangent because that's what we're looking for. And then I can click escape again because we're kind of in draw mode, and then move the hand here, hold the middle button, and then I can just grab it, and then I can just move it to extend the line. Same here, gonna extend it a little bit. Now I would like to know the equation of this line. I have to go to actions, and I would like to find out the equation. So number 8, and then I just click on the line, and here is the equation. So the equation of the tangent is y is equal to minus 4x. Now it's getting crowded here in our graph. Let's see if we can do the last one. Find the coordinates of the points of intersection of f and x and the curve g of x. So we have to plot this one as well in the same coordinate system. So minus 3x squared plus 3. Let's draw this. We just click tab, and we have the second function. Minus 3x squared minus 3 times x squared plus 3. Press enter. Okay, it looks like this. I would like to zoom out a little bit so I get a better view. Zoom out, I click around here. Now I can see it a little bit clearer. Click escape, move all these things aside. We don't need those right now. There we go. So let's move this point as well. This coordinate exactly. So they're crossing around here and around here. So let's use the tool to find the intersection. And we start a little bit to the left and then to the right. Here's one point and the coordinates for that point of intersection. Let's do it again. Analyze graph, intersection, start a little bit to the left. Here is the intersection, and then a little bit to the right, and here is the other point and its coordinates.